Okay, you have a worksheet with some problems from pre-calculus asking you to solve trigonometric equations. We are going to begin our polar unit, and when we are in the thick of the calculus, it will help to have this review. Okay, so let's just start out with this example right here. Let's remember what we're doing. Okay, we're going to be solving for x here. When is the sine of x equal to 1/2? Well, that happens at two different places. It happens at pi over 6, and it happens at 5 pi over 6. Okay, but this continues to happen as we continue to rotate throughout the unit circle. Or if you want to think graphically, okay, it's going to continue to oscillate, right, in those waves. So if we're talking about the sine or cosine, we know that that period is 2 pi. So this is going to happen every 2 pi, and we're just going to say n. So that will account for it happening every single rotation. Okay. Now, they're not going to be as simple as that, okay? My suggestion to you would be if there is a single trig function, you need to isolate the trig function, okay? Maybe before this, I had to, add the 1, divide by 2. If there is some sort of quadratic happening, you might have to factor. You might have to factor if there's a greatest common factor. You may have to use some trig identities. I know, but it will be okay. So here, this one mixes in a couple of the things that I just said, okay? Notice how we don't have a single trig function, so we can't just solve for it, right? It is quadratic, but darn it, we have sine squared and we have cosine. That's strange. Well, the good news is sine squared can be changed using our Pythagorean identity so that at least we have the same trig function throughout our entire equation. Okay. Now, I need to rearrange this, and I really dislike having a leading coefficient that's negative. So I'm going to rearrange and multiply by -1 so that I can factor this equation. Okay, so we have cosine of x and 2 cosine of x gives us our first term. Our last term needs to be 1 times 2, where one of them is negative, one of them is positive. And it looks like this will do the trick. Okay, so now we have 2 factors that equal 0. If the cosine of x minus 2 equals 0, well, that means the cosine of x equals 2. Well, guess what? That can't happen. Cosine's range is between -1 and 1, so their outputs are going to have to be between -1 and 1. Over here, when we set this one equal to 0, we get 2 cosine of x equals -1, which means the cosine of x is -1/2. Okay, well, where does that happen at? Well, there's going to be 2 places. Since it's negative, we're talking about the second and the third quadrant. So 2 pi over 3 and 4 pi over 3. And then we have to remember to add that. If we're going to express all of the solutions, we have to add on the period times n. Okay. Now, I do really quick want to talk about the case where we have an angle that isn't just x or theta or whatever. There's a coefficient with it. At this point right here, we cannot divide that 3 out. The 3 is with the x inside as the angle. So instead, we need to think about where is the cosine equal to radical 2 over 2. Well, that happens at pi over 4 and 7 pi over 4. So what we're going to say is our angle 3x equals those angles plus 2 pi n. Then at this point, we can divide by that 3. So we can take our solution to be x equals pi over 12 plus 2 pi over 3n, and 7 pi over 12 plus 2 pi over 3n. Okay, now in your worksheet, the first few examples are going to be like this, where they ask you for all of the solutions, and then the second part of the assignment is going to ask you for solutions between 0 and 2 pi, which means you would just need to give me all of the angles in that range without that 2 pi n. Okay, all right, see you tomorrow.